All right. Good morning, everybody. I assume most folks are joining me from time zones when it's still morning, but not everyone, so good afternoon in that case. This is another late breaking session. I didn't really plan it out in advance. I decided this morning that I would do a second one this week. One of the nice things about these YouTube live sessions is that they can be fairly impromptu. I don't necessarily have to plan them out in advance, and when there is something particularly interesting or important going on in the world, I can be pretty responsive to it. Honestly, I do write longer form blog posts and other things like that, and sometimes popular science pieces, but the reality is sometimes even that takes time, and so for immediate reactions to things, I don't mind this live video format, sort of responding in real time to events as they occur. I did that this past winter, of course, in California, when there was the extraordinary precipitation events for much of the season, and storms in general, and as well as the aftermath. And right now, even though it's not a California focus, there's so much popular and media attention right now on what's going on in Hawaii, specifically on the island of Maui, with respect to the now clearly catastrophic wildfire event that occurred there a couple of days ago. And it's also a place where there's a lot of complexity. Wildfire disasters are always extremely complex events. And there is a tendency to oversimplify the complexity that is inherent to these sorts of things in almost every setting in which it's discussed. And so I want to push back against the need to have single sound bites. I understand that people's in the information age, people's attention spans are short, but this is something that you really cannot get right unless you dig into the details. So I want to do a little bit more of that. The last session, I talked about the very initial emerging information about what had happened on Maui. There was a lot of uncertainty. It wasn't totally clear what the scope was or the details. Now a lot more is coming clear, although there's still a lot we don't know because the western half of the island has no functioning telecommunication system still. So this is not a case where no news is good news, and the news that has come out is actually quite bad. So I want to talk a little bit more about that, talk a little bit about also how we think about these kinds of potential threats of catastrophic wildfires, and also these catastrophic fires that kind of don't quite fit the mold of traditional wildfires. You think of a forest fire or a brush fire or a grass fire, and now we have these kinds of fires that might start out as one of those things, but then rather quickly, once they start burning through populated areas, they become something potentially quite different. That's relevant to the conversation about what happened on Maui this week, and also relevant to the conversation about what has happened in places like the Front Range of Colorado during the Marshall Fire, the Camp Fire in California, the Tubbs Fire in California, and any number of other recent events in the past 5 or 10 years, mostly in the western U.S., but also globally, including in southeastern Australia and southern Europe, where urban conflagration, and those are the fires that appear to have the greatest likelihood of causing large loss of life and extreme property damage, which again is what we're now seeing on Maui. So I want to spend about half of the hour talking about that, and then the other maybe 40 minutes, and then spend the last 20 minutes talking about California again, since I know this is a California-centric audience, and there is some stuff going on that's worth talking about from the weekend into next week. We're going to see another heat wave. It once again doesn't look especially extreme. Just to give the brief summary now. But there does look like there could be some lightning in the mountains and foothills especially, so combination of heat and some lightning potential probably will be some fire starts. And the heat wave does look more intense up in the Pacific Northwest. So up in Oregon, for example, this could be a fairly severe heat wave by Oregon standards, and there will also be some lightning up there. So I do think these are the kinds of events that tend to kick fire season into gear. It's been a relatively slow start across much of the West. This is the kind of pattern that might give it a relatively late jump start. Perhaps not so much in California, but elsewhere in the West, that's certainly true. So I'll come back to that at the end, talk about it for about 20 minutes. But I want to jump back to what has happened in Maui. A quick summary of what happened, and then some reflections. 2 days ago, there was a strong downslope wind event on the leeward side of the southernmost islands in the Hawaiian island chain. So that would be especially Maui and the Big Island, Hawaii itself, but also a little bit farther north. The winds extended up into Oahu, which in Hawaii means essentially the western side of the island. And I'm going to pause for a moment because unfortunately I see some buffering here. As I explained last time, I think I just need to get a new computer, so I gotta figure out how to manage that. But I also do have some debugging software running in the background. So if you see my eyes dart off the frame, I'm kind of trying to see what that looks like in these moments when I see the spinning wheel of death. But I won't belabor the point. Again, if anybody has specific suggestions, let me know. Otherwise, I'm not going to mention it again. If you see me pause awkwardly, I'm trying to give a pause so that the recording is more contiguous after the fact. So I'll start that sentence over again. 2 nights ago, or I believe it was, at this point, I'm losing track of the days of the week. It might have been 2.5 days ago at this point, since it was the previous evening. There was a major downslope windstorm on the lee side of the southernmost Hawaiian Islands. Lee side meaning the west side, because you have prevailing east to west trade winds in the subtropics in that part of the Pacific. And so that's the challenge there, is that we have okay. All right, there was a brief disconnection there. The challenge is that a lot of places on Earth, that is true, but those places are mostly on the windward sides and up at the top of the tall mountains that exist on many of the islands. The western slopes and all the way down to the coast on the western side of most of the islands are actually quite dry. They have semi-arid environments, not dissimilar in some cases, at least from a total annual precipitation perspective, from parts of Southern California. So I think some folks forget this, and it seems bizarre now that one of the worst wildfire disasters in modern history now appears to have occurred on the island of Maui. But it's a little bit less surprising than you might think if you actually dig into the climate of the western lee sides of the Hawaiian Islands and look at the fire histories there. Now, unlike most of the western U.S., there's not a long history of natural fires in Hawaii. That is different. And so the ecosystems in most of Hawaii are not particularly fire adapted. In fact, some are not fire adapted at all. And so the fires that do occur are essentially 100% human caused, with the occasional exception of volcanic activity. This is one of those relatively few places in the world where you do actually have hot lava flows periodically on some of the islands that can conceivably start fires. So one of the few places on Earth where the natural causes aren't just potentially lightning. But in general, the environment really didn't support a lot of natural wildfire activity, unlike many other places in the world where we've actually suppressed a lot of natural fires. That's not really what's going on in Hawaii. There is a history of indigenous and cultural burning in Hawaii, a different kind of human-ignited systems that are on the island. On the Hawaiian Islands don't necessarily sorry, losing my train of thought there because of these disconnections. Again, it's working on it. So the point being that there's not a long history of natural fires on the Hawaiian Islands, unlike many other places in the world where we do see high wildfire risk. The other challenge is that there is, in the Western U.S., we talk about the legacy of land management in the context of wildfire risk. And in the Western U.S., that often is in reference to the forests, where we artificially excluded fire. So we suppressed a lot of the natural fires and a lot of the indigenous and cultural burning that happened in the centuries and millennia previous to the present century or so. And that led to unhealthy ecosystems, buildup of dense vegetation that wouldn't otherwise have been there, increased the flammability of the forest, increased the quote-unquote fuel loading in the forest, literally adding more fuel to the fire. In Hawaii, there is also a land management component to it that actually appears to be pretty important. After talking with some of the local fire experts in Hawaii, but it's different. It's not that the forests are overstocked. It's actually that there's a real problem with invasive herbaceous plants, mainly grasses at the lower elevations in the more arid parts of the island. And part of that is because there were, especially on Maui, extensive, tens of thousands of acres, or even more, in fact, of sugarcane plantations and other plantations. So agriculture in the 20th century, where a lot of the natural landscape was converted to these uniform plant type. And then, as that industry partially collapsed in Hawaii, all of those plantations and farms were abandoned in the last few decades. And so there's a lot of places where these plantations have essentially gone to seed, and a lot of the invasive herbaceous plants and grasses have moved in. And because no one's really tending to the land, the density of that vegetation, of those grasses, has reached pretty extraordinary levels and supported pretty significant wildfire activity on the western slopes of some of the islands, and in particular Maui, in recent years, as droughts have occurred on these islands and in the dry side of Maui. There is milder drought elsewhere on the island chain, but specifically on the west side of Maui, the drought is moderate to severe right now. So drought is definitely part of the picture in the places where the most destructive fires occurred, and so anomalously low vegetation moisture is part of the story. But the big part of the story in terms of the weather is the winds. This downslope windstorm, it's not entirely clear still exactly how strong the winds were at the fire zone, but there's anecdotal reports. Originally, there were reports that it was gusting 40 to 60 miles an hour, which, as we know, in California is often more than enough to produce extreme fire behavior and dangerous spread. But there's some anecdotes that something localized went on that it might have even been more extreme, and that there folks who really know the weather and the ecology there were pointing out telltale signs that the trees, the palm trees in particular, were responding in a way that was more indicative of 80-mile-an-hour gusts. And the fire was so intense, honestly, that it's possible that it started to generate its own convective winds. And so I don't doubt that. That's possibly what happened. And some of the videos, really horrifying videos from the waterfront, cell phone videos from people who had jumped into the Pacific Ocean and were filming back towards land, kind of support this. Almost these jets of smoke and flame shooting off from the piers that were on fire, blowing out. Members were blown way out over the water, but just extraordinary scenes. And so that's sort of the setting here. The towns that were most affected, a lot of them are old, have colonial history, and the large town in particular on the west side of Maui that appears to have been devastated has had a history of fire before, though not so much wildfire, more just the fact that when you put a bunch of wooden structures close together and one of them catches on fire, that can cause some problems. A lot of the structures that were there, a lot of the old historic ones, were still wooden structures, so of course those were pretty flammable. Once the neighbors went up, it was pretty, especially in the absence of really any fire suppression ability at that point, it just went structure to structure. So you have this violent downslope windstorm occurring on the west side of Maui in the context of a moderate to severe localized drought on the already dry side of the island in the dry season. Does that sound familiar? In addition, we also have these incredibly dense fields of abandoned farms and invasive grasses immediately upwind of this coastal town that was so devastated. And really it was a perfect storm, literally. I mean, this was a downslope windstorm, but figuratively also because, it was just this confluence of factors that lined up to essentially wipe this town off the map. And unfortunately, as we're getting some visuals and pictures and reports out of the region, it really does look like the structural loss is very high, in the thousands of structures. And again, these aren't huge cities. These are population centers with maybe 10 or 15,000 people, on the largest on the west side of the island, with a lot of additional tourists this time of year. But these are not huge cities, so that's a very large fraction of the structures that actually are there on that side of the island. So, and then of course there's the human toll, which actually looks like it's going to be pretty shocking. The confirmed death toll is already up into the 50s, which already makes it the second deadliest wildfire in modern American history, second only to the Camp Fire. But based on the anecdotes and some of the pretty horrifying reporting and imagery that's circulating, which again I'm not actively sharing, it's probably going to go up quite a bit from there. And the Camp Fire, the final death toll there was in the upper 80s. There's a little bit of disagreement exactly how high the death toll was, but probably around 86 or 87. There's a pretty good chance that this event is going to surpass that, unfortunately, given how many people were caught in their cars on the highway. And this fire moved so fast that some people didn't even make it out of the buildings, apparently, out onto the street. This literally engulfed buildings within a matter of 60 to 120 seconds in some cases. I mean, I wouldn't have believed it, except that there's footage of this happening. So that is the magnitude of the event. It's genuinely shocking, and I think the news to come out is not going to be good. It's already pretty bad. Unfortunately, I think it's going to be worse. There's a list of those who haven't been accounted for yet that's in the 4 figures. There was also a similar list that long in the wake of the Camp Fire in California back in 2018. Fortunately, over 90% of the people who were originally on that list did in fact make it out, but a lot of them lost their homes and potentially didn't even lost their ability to communicate with people, lost their cell phones, got left behind, and the cell networks were down for days in the area. So it's likely that most of the people on that list just can't reach out yet, but still the confirmed death toll is already really high. And there were some extenuating circumstances here that in some ways may have made it even deadlier than the Camp Fire, in the sense that this fire moved unbelievably quickly and there was very little awareness of what was happening or that the risks even existed. At least, I suppose, in Paradise, most folks who lived there knew that they lived in a fire risk zone. I don't think that's true necessarily of people who lived on the west side of Maui, and in particular the tourists who were there. And the number of tourists can double the population of the town. Imagine if Paradise had its regular population plus 10 or 15,000 tourists when the Camp Fire hit. So it's a completely different story. Folks don't necessarily know the street network, so a lot of people were self-evacuating to the coast, to the harbor, literally jumping in the Pacific Ocean to escape the flames, in many cases successfully, although I can't imagine how awful that experience would have been. But even to be able to do that, you at least needed to know which streets were the quickest shot to the ocean, and there were traffic jams, cars were crashing into each other, there were lots of traffic incidents, visibility was zero, there were power lines down over the road, and there were flaming buildings collapsing into the road. Very disaster movie-esque. The footage, again, is really hard to believe. But I think if not all tourists necessarily have access to a personal vehicle. Some people are taking taxis or Lyft to get around or something, and those certainly weren't available during the disaster. So then you're sort of at the mercy of whoever you could flag down, or whether you were on foot to run to the ocean. And again, you kind of needed to know where to go in a period of zero visibility, extreme chaos, and flames in every direction but one. So it's understandable that people were really panicked and that it was chaotic. And I've reflected that I don't know at this point if the town or the county of Maui had a specific wildfire evacuation plan, but like in Paradise, which did have a comprehensive evacuation plan prior to the campfire, I'm not sure that it would have helped that much in this case, because this fire moved so quickly. It ignited immediately upwind of town in the brush and grass. It was starting to burn structures almost immediately. And then it started burning structure to structure, became an urban conflagration. So I don't know necessarily that having a plan would have even helped. It's usually better to have one than not, of course, and there are many other types of events where evacuation plans are tremendously helpful and save a lot of lives. But in these instances of extremely fast-moving, wind-driven fires that ignite in close proximity to highly populated areas and then start burning through them, I think we really see these evacuation plans break down, because there just isn't physically enough time to get the information to people, and even if you could, to get people out of harm's way fast enough. And so I think this is just a real tragedy. So there's this confluence of factors. There was extreme weather in the forms of a strong downslope windstorm and very dry air. Some of that downslope windstorm may have been contributed by the indirect influence of a Hurricane Dora to the south, although it's possible that influence has been a bit overstated. I do think it was a factor, but I don't think it was the main factor. The evidence doesn't suggest that it was. We have this pre-existing moderate to severe drought, and then we had the legacy of these abandoned plantations and the invasive grasses that were, again, thousands of acres of this immediately upwind of the fire area and of the town. And so all of that contributed to what now appears to be certainly among the top 3 worst wildfire disasters in modern American history, and in terms of the death toll, it may end up becoming the deadliest. Which is, even to folks I think who study wildfires and wildfire disasters, the fact that it's reasonably likely that by the end of the week we'll discover that the worst wildfire in modern American history in terms of the human toll will have been in the Hawaiian Islands on the island of Maui. That is pretty stark. But it also points to, I think, a reality that we sometimes forget, which is that the risk of such events is higher in many places than I think many folks realize. And that the conditional risk of a wildfire catastrophe is high in many hundreds of small to medium-sized towns, and probably even some cities in the U.S. and globally. And some of these spots are obvious, like the foothills of California or the suburban areas ringing, Los Angeles and San Diego. Everybody knows that these are places that are susceptible to Santa Ana winds that can drive extreme wildfires and wipe out neighborhoods. There's no surprises there. The Sierra Nevada foothills, these are susceptible to autumn windstorms, similarly destructive wildfire potential. So that's not a great surprise. But there are other places I think that are probably more surprising, and I've spoken about that before in other contexts, but I just want to mention that wildfire experts, and in particular those who study urban interface fires, so wildland-urban interface, meaning wildfires that burn through populated areas and therefore through the interface of vegetation and structures, homes, businesses, what have you. Will highlight, of course, California and Colorado and Oregon, these places that you'd expect, Arizona, but also places that may be somewhat more surprising, like Texas, Florida, places that are much wetter on average than California, including during the warm season, but that are also susceptible to severe droughts and extreme wildfire conditions occasionally. So it doesn't happen as often. You don't get major fires every year in some of these wetter places. But if you have a severe enough drought, even if it's a flash drought, flash droughts, of course, are the kind that are becoming most clearly becoming more frequent and intense in a warming climate because they have to do directly with the thirstiness of the atmosphere. So the flash droughts are driven more by extremely high evaporative demand rather than low precipitation necessarily. Those are the kind of droughts we're seeing more of as our atmosphere becomes thirstier overall. These are the kinds of places that you might go years in between major wildfire activities, and so people let their guard down. It isn't as much in the public awareness. These places don't necessarily have as advanced of wildland firefighting capabilities as a place like California, and so then when something happens, it's a much bigger problem because there's even less preparedness, and yet the conditions are just as extreme as they would be in a place like California. So, the Deep South, even parts of the Gulf Coast region are at risk. The Blue Ridge Mountains, the Appalachians, again, doesn't happen that often, although we have had a couple of instances in recent years of destructive wildfires. There was one near Gatlinburg a few years back. The New Jersey Pine Barrens and some of the coastal towns downwind of them in New Jersey, very high risk, conditionally, of a catastrophic wildland-urban interface fire that would burn a lot of structures and put a lot of lives at risk. Upper Midwest, Wisconsin, the Upper Peninsula of Michigan. These are places that occasionally see wildfires in the contemporary era. We haven't seen really destructive ones in a long time, but if you go back far enough, a century or so, there is a history of truly catastrophic, multi-million acre fires. That the Great Peshtigo fire, for example, that burned a couple million acres and killed many, many people up there. So I think the challenge is that we often underestimate the risks that these kinds of catastrophes can occur, and a lot of folks, I think, live in places where it's at least conditionally possible and don't even realize it. And this is a difficult challenge because on a lot of these places, the risk is usually pretty low. So unlike California, where it's common to see moderate to high fire danger, moderate to high is just kind of the default state in a typical summer or autumn, right? That's not unusual. But the truly extreme days are still somewhat less common in California. But in some of these other places, you don't really get that high background level of moderate to high fire risk. It's mainly low, except that under the right confluence of conditions, it can be extreme. And, we've seen this in parts of Europe this summer and last summer, places that rarely see damaging fires have seen them. And this is the kind of thing, when we talk about climate change and wildfire, the clearest link is to the drying of vegetation, fuel drying. So essentially the increased thirstiness of the atmosphere as what's known as the vapor pressure deficit increases in a warming climate. That tends to dry out vegetation more quickly than would be the case otherwise. And in addition to this, there is evidence in many places that we see more variability of precipitation. So not necessarily large changes in the average precipitation, or even in places sometimes where the average precipitation is increasing, we see that it's falling in shorter but sharper bursts. So you get more intense precipitation, but more dry days in between, allowing for the potential for more evaporation. And of course, if you add together the fact you have more dry days in between with the fact that the atmosphere is evaporating water more quickly when it's sunny out to begin with, well, then you start to see why you can dry out vegetation faster, induce flash droughts more readily, rapidly developing droughts that have a particularly strong evaporative demand, atmospheric thirstiness component to them. And I think, in the context of what's unfolding in Maui and the climate change part of the conversation, when it comes to wildfires globally, there's a clear link between wildfires and climate change, but a lot of that link comes from certain kinds of ecosystems more clearly than others. So in forests, the link between wildfires and climate change is extremely clear. In particular, in forests and semi-arid regions, or regions that have susceptibility to droughts, it is very clear that when you even incrementally start to dry out the forest, that you greatly increase fire activity. And this is true across a range of forest types, all the way from the semi-arid ponderosa pine forests in the southwestern U.S., to the boreal forests and the much wetter Canadian and Siberian Arctic. It's true in the tropical rainforests. We've seen fires in recent years in the Amazon, and in Indonesia. And so, in forests that are known as a moisture limitation, you dry things out and you definitely increase fire activity. So the links between climate change and wildfire in those settings is really clear. And then in other settings, it's also fairly clear, but it's a little bit more nuanced. In a lot of places that are semi-arid environments with large amounts of grass and brush, this is true for big swaths of California, by the way, it's not always true that the very driest possible conditions lead to the most wildfire activity, because if you live in a place where there's sparse enough vegetation, you actually need wet conditions to grow extra grass and brush to provide enough fuel to have those intense fires. So sometimes the worst possible environment for wildfire in those regions is actually very wet conditions followed by very hot and dry conditions. And that too is a condition that appears to be increasing, both in parts of California and in many other regions that are fire prone. So there too, there are probably links to climate change, and we've shown that more strongly in some such regions than others. And I think that that's sort of where we are with the question about Hawaii and the dry side of Maui in particular. I think the role of climate change and some of the changes in wildfire activity, behavior, and damages we've seen, it varies from event to event and from region to region, and of course ecosystem to ecosystem. In some cases, it's actually the main story. And I think that's increasingly true in some of the very large forest fires that we see throughout the northern hemisphere and parts of the southern hemisphere as well. In other places, it's still there, but it's maybe not the main part of the story, and I would tend to think that's probably where we fall with the situation that's unfolding. Evidence that there is evidence that climate change is bringing about, of course, warmer temperatures in Hawaii and an increasing thirstiness of the atmosphere, as it is just about everywhere. So that piece is true across a wide range of ecosystems, but also specifically on the dry side, on the lee side of islands, there has been a trend towards drier conditions overall in recent decades, and that is consistent with what we expect to happen under climate change. So that the parts of the island that are already driest and most fire prone will become even more so. And that part of how this unfolds is that problematic combination of more intense precipitation when it does occur, but longer dry spells in between. So that's precisely the kind of environment that fosters higher risk of fires in grassland ecosystems, because you still get the moisture for all that growth of grass, but then you dry it out even more. You add fuel to the fire, and then you dry out that fuel more than you used to. So I do think, and there's published evidence on this in Hawaii, that the dry side of the islands in particular become more fire prone, that the risk of drought increases during increasingly strong El Nino events. El Nino events often bring drought, especially to the dry side of the Hawaiian Islands. And that we see longer dry seasons and longer dry spells within wet seasons, even though the wet season precipitation may not decrease. In that sense, that's somewhat similar to what we expect in California. So is there a climate change component to what's going on Maui right now? Probably yes, but in this instance, I don't think it's a poster child for the influence of climate change on wildfire. I think the poster child events of this summer would be, say, Canada, the extraordinary record-shattering fire season we're seeing, mainly forest fires, where the drying signal due to climate change is unambiguous and the risks have clearly increased due to climate change. So I think that that's mostly what I wanted to say about Maui. More information is going to continue to come out, of course, in the days to come. A lot of it's going to be kind of grim, unfortunately. And the death toll is going to be really high. I hope it's not dramatically higher than it is now, but there does sound like there's some potential for that as they send crews in. There's still been very little news crew, television crew access because there isn't much way to get a signal out on that side of the island. They can't do live broadcasts easily. They're sort of having to record things and then bring them back to the other side of the island where there's power and internet connectivity. So we'll see how that goes. But I think this, unfortunately, again, will likely end up, is already the second deadliest wildfire in modern American history and has a pretty good shot at becoming the deadliest. And by the way, some folks have asked why I make that modern American history distinction. There have, of course, been wildfires in American history going back a couple of centuries that were deadlier, but I think it's important to make a clear distinction between the wildfires that occurred prior to really the advent of wildland firefighting. The era in which there was essentially nobody there to do anything about wildfires. Cities might have had fire departments in a limited capacity, but there wasn't anybody. If there was a forest fire, it pretty much just did what it wanted to do until it burned itself out. There were no aircraft, there were no hand crews, there were no wildland fire engines, nor any organized way of dealing with them prior to the earlier part of the 20th century. So really what I'm saying is modern American wildfire history, there are fire historians who would probably quibble with this, but I'm calling it the last century or so from the present. So that's sort of why I'm making that distinction, is that there is an important difference between wildfires burning in the context of a relatively sparsely populated landscape compared to today, where there's essentially no wildfire suppression capability, versus in many cases, and also a lot more people living potentially at risk in that landscape. All right, I want to quickly let me quickly take a look at the questions pertaining to Maui, and then I'm going to move on in the last 20 minutes or so to talk about California. All right. Let's see here. Yeah. A lot of folks who are commenting that they personally had experiences with either the Camp Fire or the Tubbs Fire, and that was, of course, traumatizing, and that seeing it unfold again is not a good feeling, to probably put it quite mildly. And that's true. I mean, I can only imagine. We had our brush with it in Colorado with the Marshall Fire, which was really close to home, literally. We were in Marshall Canyon about 5 minutes before it started in that insane windstorm. And again, that's another parallel, really, because that was a fire that was probably about 1,000, 2,000 acre wildfire that became an urban fire, burning structure to structure shortly thereafter. And so seeing that burn from structure to structure and to just take out whole neighborhoods was pretty sobering. I mean, you study the stuff, and then it happens right up close. Running errands, that's why we had driven through Marshall Canyon. I just remember shaking my head and saying, man, if there were ever an ignition in this canyon during a windstorm like today, it would just be catastrophic. And literally 5 or 10 minutes later, that is in fact exactly what happened. So sometimes it gets a little hard to whistle past the graveyard when you know these things. Yes, there's a comment from Cheryl about Oregon and the heat wave this week. I'll save that for a moment. Just bear with me. Let's see. Yes. Comment from Aaron that, about worry that a catastrophic downslope wind event could happen in the San Gabriel Mountains in Southern California and bring a massive fire through the San Gabriel Valley. I mean, yes, there have been a lot of instances of this. Southern California probably has the best wildland firefighting capability of anywhere in the world by a pretty wide margin. So you've got that going for you. Under the most extreme conditions, there's not a lot you can do, and that's, I think, the big concern. But it's a bit different. But yes, I mean, there are lots of places in the valley areas in California that are viewed as being at pretty low risk of fire, and they are 99% of the time. But during the 1% of the time that you have a truly extreme downslope windstorm plus severe drought, then yes, I think what we're realizing is that the WUI, the wildland-urban interface, extends much farther into populated areas conditioned on extreme windstorms. So pretty much the key element there is you need very strong winds and very dry fuels. And you can have very dry fuels and get a major wildfire, but generally the risk to properties under those settings are at the margins of populated areas, so the edges that, abut open space and forest and brush. But under very strong wind events, you can start to get fires that hopscotch into neighborhoods. And once they get going in neighborhoods and it becomes an urban conflagration, then your backyard vegetation becomes, your garden becomes part of the wildland. The highway medians with brush and trees in them become part of the wildland, and all of a sudden you have a hybrid fire. And so I think it really is the extreme winds that differentiate the risk of those events, and those are generally rarer. Hot and dry, that happens a lot, and you get fires, but you don't get this kind of catastrophic urban fire. But when it's dry and very windy, that is when things can really go off the rails. So I think there probably should be more focus on extreme winds in planning for these sorts of events, because I think they are qualitatively different types of fires and how they behave, and in terms of, in particular, the risk of loss of life, you can still get large structure losses in a hot and dry type fire environment, but usually there's at least time for people to physically get out of the way. When you have a really big windstorm, unfortunately, as we've now seen multiple times, that's not always going to be the case. All right. So I'm going to talk a little bit about California and the West Coast heat wave that's upcoming. Looks like heat is going to ramp up this weekend as a fairly strong ridge builds along the West Coast, and really broadly across much of the West, so including Western Canada too. The peak anomalousness of the heat is actually going to be up in Oregon and parts of Washington and the interior Great Basin. So again, this will not be a heat wave that is primarily focused on California, although the very northern part of California, so Mount Shasta City, sort of Shasta County northward, it is going to be extremely hot up there. But elsewhere in California, it will be merely moderately hot. Nothing extraordinary necessarily, but it'll be a fairly prolonged heat event in some. It will contribute to August probably being a much hotter month on average than previous months in many cases, and so I think the string of below average temperatures in California is officially over at this point. So Northern California the far Northern California will be the hottest part of California in this event in relative terms, but it's going to be pretty hot everywhere except for the immediate coast. And it may even get relatively warm along the coast because there may even be some weak offshore flow this weekend. Nothing strong, nothing alarming, but enough to potentially suppress the marine layer to the extent that the beaches could be quite pleasant and the inland areas will get pretty toasty. Up in Oregon, though, this will be a more severe heat wave. It's much more unusual to get temperatures over 100 degrees in the inland valleys east of the coastal mountains in Oregon, and that'll happen this week, starting this weekend and into early next week. So that'll have greater heat-related impacts up north, closer to the ridge axis. And on top of this, there will be the potential for some modest level of thunderstorm activity, probably a mix of mostly wet but maybe a few dry thunderstorms, all the way from the Sierra Nevada in California, the northern mountains in California, and then up and down the Cascades as well. Some of these storms, at least there's a slight chance that they might spill westward since they're going to have an east to west trajectory on the east and northeast side of a low pressure system off the coast of California, which is actually associated with the remnants of former Hurricane Eugene. That's the same low pressure system that has brought some shower and isolated thunderstorm activity to parts of the central coast over the past couple days. In fact, there's a few rain gauges along the central coast that actually saw some decent rainfall yesterday. Most places did not. Most places are maybe completely dry, but some isolated spots saw some nice downpours yesterday. There may have been a couple of minor lightning-ignited fires, but nothing that's really of concern. There was not extensive dry lightning. I am not expecting a large dry lightning outbreak this weekend either, with the caveat that the models don't always represent these patterns perfectly, and there will be thunderstorms clearly over the mountains, and some of those storms may drift out over the foothills or even the Central Valley, even the inland valleys of Oregon, and that could result in some drier strikes that could start some fires potentially. That's more of an isolated potential. This is not going to be like an August 2020 type event by any expectation, but there could be some lightning-ignited fires. There probably will be some thunderstorms, perhaps in some unusual places in parts of California and Oregon. I don't think the Bay Area is likely to see lightning out of this, although I guess there's a slight chance that things move farther west than expected. Same thing with the Central Valley. The northern part of the Sacramento Valley is probably the likeliest place to see that kind of activity, if anywhere. So again, there probably will be at least a handful of lightning fires, perhaps more than a handful, and they may start to become a little bit more problematic because they will be occurring either before or in the midst of a major heat wave in the region, particularly in far northern California and up in Oregon. So there is going to be elevated fire weather risk this weekend. It doesn't look like it's going to be extreme, but it definitely looks like it's going to be more elevated than we've seen recently, both in terms of the potential for lightning ignitions and the potential for fires to behave a little more aggressively as things continue to dry out and as the heat is present. This might set the stage for a more active fire pattern over the next month or so too, because now things are really starting to dry out, and some of the lightning fires, if there are more than a few that start right now, this is the time of year when you do get lightning fires in remote areas, they tend to linger for weeks, and therefore they can be still burning when the stronger offshore autumn drying winds do arrive. So, the risk of autumn lightning ignitions is always that they burn until September, when the downslope winds can really blow those fires up and cause much bigger problems. So that's, I'm not super worried about really dangerous fires necessarily in the next week, but it could, we're going to see more activity, and it could set the stage for more concerning fires in a few weeks down the line, depending on how things go, since it does look like it's going to continue to be warmer than average for the foreseeable future for most of California. Again, not extremely so, but that is a change from earlier this summer. Also, in terms of ocean temperatures, and this is important right now, the nearshore waters in California have been extraordinarily cool in recent months, but in this very narrow strip right along the coast. So it's really enhanced the marine layer, led to chilly conditions along the beaches. But just offshore, there's actually been a pretty extreme, even record-breaking marine heat wave, believe it or not. So you only have to go a couple hundred miles offshore to reach a 1,000-mile expanse of extremely warm ocean water. So the water to the west of San Francisco is actually in the low 70s Fahrenheit if you go far enough west. But right along the immediate coast, it's still in the 50s because of that upwelling near the Farallones. But you do not have to go that far, and that extreme warmth in the ocean has been creeping closer and closer to the coast in recent days and weeks, and it might end up getting fairly close to the coast in the weeks to come. And if that happens, there's going to be a pretty dramatic shift from cooler than average temperatures along the coast to warmer than average temperatures along the coast. I don't know exactly how close this is going to get to the coast, but it's starting to exert its influence. So this is a major, depend on the NOAA definition, Category 3 or 4 marine heat wave to the west of California right now that's been creeping slowly closer. If that really warm water body makes it to the coast, we're not going to see 70-degree water temperature right off of San Francisco, because you still have upwelling, and so that still makes it much colder than the water temperature even a couple hundred miles offshore. But if you start to inhibit that upwelling even a little bit, you do see some pretty substantial increases in water temperature. So we'll see what happens. This does sometimes happen during strong El Nino years as coastally trapped Kelvin waves can inhibit upwelling. We haven't really seen that yet this year,
that might yet happen because El Nino is finally looking like it's getting into gear. There's finally looking like it's getting into gear. NOAA officially is predicting a more than 2 in 3 chance of a strong El Nino event for this coming winter. So if that's going to happen, it's going to have to continue to strengthen between now and then. So stay tuned for more conversations about that later. But for now, it looks like California in general is probably done with the unusually cool weather for the year. I don't necessarily see any obvious extreme heat events right now, but it is going to be very hot across the interior with this heat wave coming up, in particular across the northern interior. That heat wave will be more extreme up in Oregon, and since it will be coupled with at least some lightning activity, mainly focused over the mountains but locally drifting elsewhere, there probably will be some fire starts, some new ignitions that are going to start to be a little spicier than the ones we've seen earlier in the year. So that's sort of what I'm thinking right now. I'll try and have a blog post tomorrow. It's been a very busy period, so it's been hard to find the time to do that. But I think that's really the story for the next week. Nothing extreme for California, but something notable anyway. And it is possible that these remnant tropical cyclone moisture events, they're always a little bit tricky, and there is at least a slight chance that we end up seeing something more widespread in terms of high base shower and thunderstorm activity than anticipated. And if that's the case, I'll either include it in the blog post or talk about it on Twitter. Right now, I'm not seeing a huge likelihood of something widespread, but we sometimes miss this. So these are the sorts of events that we're not great at predicting. So I never want to make too confident a statement that nothing big is going to happen, because we don't always know exactly. All right, well, I want to take a few more minutes to just review the comments about what's going on now in California and Oregon, just to see if there are any burning questions regarding the second half of this conversation. Let's see here. All right. Well, I think since I have to run off and tape a Weather Channel segment later this afternoon, so I will probably sign off for now. I'm still looking to figure out what the heck is going on on the technical side. It actually looks like it might be on the YouTube server side. Interestingly, looking at my debugging, it's the connection's getting dropped despite very high bandwidth internet. So it's maybe not my computer. Maybe it is something in the fiber optic world, and the cables connecting me to the broader internet. So I got to figure out if that's the cables in our home, if it's something on the street, or what. Hopefully it's something I have some control over anyway. But with that, I think I will close. Keep an eye out for a potential new blog post this weekend. I'll probably have a live session again next week where I'll talk about whatever is in the news and whatever's going on in the weather along the West Coast at that point. So thanks for listening. As always, this will be very lightly edited and then available via YouTube as a recording thereafter. And yeah, the course, the low resolution version will probably be available immediately, and then the improved one will be up. Usually takes a few hours for it to process. So thank you, everybody, and I'll talk to you